Hello friends, very good morning to all of you. So today we are going to discuss OpenID Connect, that is PF37. So we discussed a lot about SAML. We understand the SAML flow. We onboarded a SAML application. We have done a few testing also. Then we jumped to OAuth. We tried to understand what is OAuth. We implemented OAuth in PingFederate. We just tried to understand different grants in OAuth, and then we have onboarded an application in OAuth also, and we have tested. Now we're jumping to the OpenID Connect. Okay, so let's try to understand what is exactly this OpenID Connect and how it's beneficial for the applications or for the use cases what application have to make their authorization authentication flow more in a easy way and more secure way. So we just try to understand that part, and yeah, maybe you will be able to understand the things what is happening around SAML, around OAuth, around OpenID Connect. So we can talk later also, like for an example, if you have because OpenID Connect and SAML both are authentication protocol, you can say, and OAuth is a like a authorization or a delegation protocol, you can say. So we can just compare, like if your application have a choice that whether you can go for the SAML or you can go for the OpenID Connect, so what can be the preferable and why. So we'll just try to understand later, but yeah, but you will also understand once you have the understanding of this or the OpenID Connect and SAML, you can able to understand, or you can able to advise the application teams that okay, you need to prefer OpenID Connect over SAML, and what is the reason for that. Okay, so we can talk on those things later. Yeah, let's begin. So today we'll discuss PF37, that is OpenID Connect, a standard for authentication and identity on top of OAuth 2.2. Okay, so we discussed SAML, we discussed OAuth, and now we are going to discuss OpenID Connect, and thereafter we can discuss on WS-Fed and WS Trust also. So let's try to understand in OpenID Connect what all the informations, what is basically OpenID Connect, and then we can just go for like implementation in PingFederate, and then we can try to do some test with some test connection, and also we can try to onboard Salesforce to PingFederate using OpenID Connect. In OAuth we face some challenges, so yeah, I think OpenID Connect will work as expected, so we can see that. So let's I'll just let me present this. I think you're able to see my screen. So this is, yeah, the first thing. Let me go to the next slide. Okay, so OpenID Connect is an open standard published by the OpenID Foundation in okay, so we are in PF37, and today we'll discuss OpenID Connect, that is a standard for authentication and identity on top of OAuth 2.2. We discussed about SAML, we discussed the test case, we discussed about OAuth, we discussed the different grants and the test, and also we tried to onboard Salesforce used with PingFederate using OAuth, but we have seen some challenge. I think it will fix. We can fix those challenges in OpenID Connect, so we can see that. So let's quickly discuss on OpenID Connect, and I'll just quickly present that the PPT that I presented, and then we can discuss, and then yeah, we can go for the next like the implementation and the integration of the Salesforce like app with the PingFederate using OpenID Connect. Okay. So OpenID Connect is an open standard published by the OpenID Foundation in Fab 2014 that defines an interoperable way to use OAuth 2.2 to perform user authentication. Okay, as an open standard, OpenID Connect can be implemented without license or intellectual property concerns, since the protocol is designed to be interoperable. An OpenID client application can speak one protocol to many identity providers instead of implementing a slightly different protocol to each identity provider. Okay, so this is very new. It's built like it's just like built by OpenID Foundation in Fab 2014, so it's not too old. Maybe you can just see it's just 10 years like from now. So it's just built on the top of layer of OAuth only. So maybe in coming time, maybe you can see some new things can be arise, definitely can be built on the OAuth platform to make the things more better. Yeah, if there is anything which can be improved. So OpenID Connect is built directly on OAuth 2.2 and remains compatible with it. In many instances, it's deployed along with a plain OAuth infrastructure that protects other APIs. In addition to OAuth 2.2, the OpenID Connect uses the JSON object signing and encryption suite of specifications for carrying signed and encrypted information around in different places. Okay. So in OAuth, we talked about access token, right? We have JSON Web Token, JWT. We have internally managed reference token. That's a type of the access token. Along with that, we need to understand ID tokens also. That is there in the OpenID Connect. Okay, so what is that? So the OpenID Connect ID token is a signed JWT only, JSON Web Token, given to the client application alongside the regular OAuth access token. Unlike the access token, the ID token is directed to the relying party. Okay, that's the application, you can say, and is intended to be passed by it. Okay, so they can pass that, like how they're passing the access token. Let's go to the next slide. So what we have, claims inside an ID token. So these are the standard, but it's not only this much. You can pass additional claims of the user also in the ID token. That is the user membership, user title, user groups, user role. Okay, these informations, whatever present in the directory server, you can pull those and add in the ID token. So you have the ISS, that is the issuer of the token. Then you have the SUB, that is the subject of the token, a stable and unique identifier. For the user at the IDP, this is usually a machine readable string and should not be used as a username. Then you have AUD, that is the audience of the token, must contain the client ID of the relying party. That's going to be the audience, right? Then you have EXP, that is expiration timestamp of the token. All ID tokens expire and usually pretty quickly. Yeah, maybe we can see that, like the ID token have the list lifetime, maybe it's 5 minutes default. We are using, as well as for the access token, we have like 120 minutes, 60 minutes to 120 minutes. Then you have IAT, that is a timestamp when the token was issued. Then auth underscore time, that is a timestamp of when the user authenticated to the identity provider. Then you have nonce, that is a string sent by the relying party during the authentication request, used to mitigate replay attacks, similar to the state parameter. As you have seen, we have discussed about the state parameter. It must be included if the relying party sends it. ACR, that is the authentication context reference, which indicates an overall categorization of the authentication that the user performed at the identity provider. I think you already know for the context. We have seen in SAML case also. AMR, the authentication method reference, which indicates how the user authenticated to the identity provider. AZP, the authorized party for this token must contain the client ID of the relying party if it is included. AT underscore hash, that is cryptographic hash of the access token, and C underscore hash is the cryptographic hash of the authorized code. Okay, this is the basic thing. We have the standard in the claims inside an ID token, but along with that, we have other things as I discussed, like department title, membership of user group roles, and all those things. The ID token represents a single authentication event, and it's never passed to an external service. The access token can be used to fetch protected resource long after the user has left. Although it's true that you could still use the access token to ask who authorized the client in the first place. Doing so would not tell you anything about the user's presence. You are getting what is the meaning of this line? So it says the ID token represents a single authentication event, and it's never passed to an external service. Okay, that means to the talking about any third-party service. The access token can be used to fetch protected resource long after the user has left. Although it is true that you could still use the access token to ask who authorized the client in the first place, because access token also have the user information like SUB, the user ID, like that. So it can be. Doing so would not tell you anything about the user's presence. Okay. Finally, the ID token itself is signed by the identity provider's key, adding another layer of protection to the claims inside it, in addition to the TLS transport protection that was used to get the token in the first place. By applying a few simple checks to the ID token, the same checks used when processing a signed JWT, a client can protect itself from a large number of common attacks. Yeah, we have a separate session. Definitely we can talk about more vulnerabilities in the OpenID Connect, and we can see how we can fix those also. So while passing the ID token to ensure it's a valid JWT and collect the claims. So split the string on this dot character. Okay, then you have base 64 URL to decode each section. Then you have passed the first two sections, that is header and payload, as JSON. First you are doing this, parsing that, and then validating the signature of the token against the public key of the IDP published at a discoverable location. Then you have seen that the ID token is issued by a trusted identity provider. Ensure that the client's own client identifier included in the audience list of the ID token. Okay, and then you have confirm that the expiration issued at and not before timestamp values are reasonable given the current time. Make sure that the nonce, if present, matches the one sent out. Validate the hashes for the authorization code or access token if applicable. So each of these steps is deterministic and mechanical, requiring minimal coding effort. So more advanced modes of OpenID Connect allow for the ID token to be encrypted as well. You can encrypt that also. Yeah, that's how in the PingFed also we have that option, which changes the parsing and verification process slightly, but the same result. Yeah, that's the same thing, but yeah, you need to again just maybe if you remember that we discussed about the signature, there's a signature section in the earlier session. So like how you can just decrypt that, right? So you have the private key, so you can able to decrypt that the encrypted token getting sent by the PingFederate or the any other authorization server. Okay, let's go next. Now you have UserInfo endpoint. What is this? Since the ID token contains all the necessary information for processing the authentication event, OpenID Connect clients don't need anything more than this to process a successful login. However, the access token can be used at a standard protected resource that contains profile information about the current user, which is called the UserInfo endpoint. We can see this, we can test this in PingFederate, right? Once we I'll show you in Postman, maybe in the next session. So the claims at this endpoint are not part of the authentication process previously discussed, but instead provide bundled identity attributes that make the authentication protocol more valuable to application developer. The request to the UserInfo endpoint is a simple HTTP GET or POST with the access token sent as the authorization. That means it's an endpoint which is going to give a user profiles information. That means there's an endpoint UserInfo, you are trying to hit that using HTTP POST method, and in that you need to as you need to authorize, so you need to just send the access token in the authorization, and then you can just use this endpoint to get the claims, to get the user profile claims. Okay. The response from the UserInfo endpoint is a JSON object that contains claims about the user. These claims tend to be stable over time, and it's common to cache the results of the UserInfo endpoint call instead of fetching them on every authentication request. Using advanced capabilities of OpenID Connect, it is also possible to return the UserInfo response as a signed or encrypted JWT. Okay. So OpenID Connect defines a special OpenID scope that controls overall access to the UserInfo endpoint by the access token. The OpenID Connect scopes can be, this is another important thing. OpenID Connect defines a special OpenID scope that controls overall access to the UserInfo endpoint by the access token. The OpenID Connect scopes can be used alongside other non-OpenID Connect OAuth 2.0 scopes without conflict, and the access token issued can potentially be targeted at several different protected resources in addition to the UserInfo endpoint. This approach allows an OpenID Connect identity system to smoothly coexist with an OAuth 2.0 authorization system. Okay. Now you have mapping OAuth scopes to OpenID Connect UserInfo claims. So these are the scope like OpenID, profile, email, address, phone, and you can do the mapping of the claims like OpenID is a SUB which have the username or the email address, whatever you configured. Then you have the profile which have the name, family name, given name, preferred username, profile, groups, department title, like that. Then you have the email which have the email and the email verified claims. Then you have the address which have the address, a JSON object which itself contains formatted street address, locality, region, postal code, country. Then you have the phone which have the claims like phone number verified like this. So you have the scope and you map this scope to these claims. we can see in PingFederate, right, while we do the integration. Go next. Then you have dynamic server discovery and client registration. So OAuth 2.0 was written to allow a variety of different deployments, but by design does not specify how these deployments come to be set up or how the components know each other. This is acceptable in the regular OAuth world, in which one authorization server protects a specific API and the two are usually closely coupled. OpenID Connect defines a common API that can be deployed across a wide variety of clients and providers. It would not be scalable for each client to have to know ahead of time about each provider, nor would it be at all reasonable to require each provider to know about every potential client. To counterpart this, OpenID Connect defines a discoverable protocol, you can say, that allows clients to easily fetch information on how to interact with a specific identity provider. So you have some address, you can just use that, and you can before the integrating the connection, you have the details of like how I can interact with this identity provider with the token endpoint, authorization endpoint, UserInfo endpoint, and all those information. This discovery process happens in two steps. First, the client needs to discover the issuer URL of the IDP. You need the issuer URL. If you remember, I shown you in the OAuth. I'll again show you quickly. And then after the issuer is determined, the client still needs essential information about the server, such as the location of the authorization and token endpoints. This is discovered by appending this /well-known/OpenID configuration to the issuer URL discovered in the first step and fetching the resulting URL. This returns a JSON document containing all the attributes of the server that the client needs in order to start the authentication transaction. I can show you the example, but yeah, like I'll show you quickly in our case also how it looks. We have the issuer. When we attach that OpenID the address I shown you here, .well-known OpenID configuration, then you are able to see the complete the endpoints like the issuer, request parameter. As you can see in this example, token endpoint, authorization endpoint. I'll show you quickly. Yeah, this is one of the example. So once the client knows about the server, the server needs to know about the client. For this, OpenID Connect defines a client registration protocol that allows clients to be introduced to new identity providers. The OAuth Dynamic Client Registration Protocol extension was developed in parallel to the OpenID Connect version, and the two are compatible with each other on the wire. By leveraging discovery, registration, a common identity API, and user choice, OpenID Connect can function at internet scale. Even when no parties have to know about each other ahead of time, two compliant OpenID Connect instances can interact with each other to effect an authorization protocol across security boundaries. That's the advantage of the discoverable, yeah, that we talked. Discovery, registration, and the common identity. Let's discuss two more things, and then we can quickly, and then I need to show you the diagram also for the OpenID Connect. It's just like the same authorization code we can talk, and I'll just show you some more thing there, like what is extra parties coming in this OpenID Connect. So you have compatibility with OAuth 2.2. So even with all of its robust authentication capability, OpenID Connect is by design still compatible with plain OAuth 2. In fact, if a service is already using OAuth 2.0 and the JOS specifications, including JWT, that service is already well on its way to supporting OpenID Connect in full. To facilitate the building of good client applications, the OpenID Connect working group has published documents on building a basic OpenID Connect client using the authorization code flow as well as the implicit OpenID Connect client. Okay, you can just check that in the openid.net website. You can able to get more information for that. Both of these documents walk the developer through building a basic OAuth 2.0 client and adding the handful of components necessary for OpenID Connect functionality. Okay, so using these two grants like authorization code flow, as you have seen in OAuth, and as well as implicit, yeah, they have just published that document how you can use this a basic OpenID client. They just the group has published, like it can help you to build that client, and you can go for the testing, and you can see the functionality also. Okay, we can talk, like maybe I'll just show you the example quickly using authorization code flow, how we can understand that the OpenID Connect. Advanced capabilities what it have. So an OpenID Connect client can optionally authenticate using a signed JWT in lieu of the OAuth's more traditional shared client secret. This JWT can be signed with the client's asymmetric key if it registers its public key with the server, or it can be signed symmetrically with the client secret. These methods provide a higher level of security for clients, which avoid sending their password across the network. That is cool. Next one is, similarly, an OpenID Connect client can optionally send its request to the authorization endpoint as a signed JWT instead of a set of form parameters. As long as the key used to sign this request object is registered with the server can validate the parameter inside the request object and can be assured that the browser did not tamper with them. That's a common digital signature concept. Then an OpenID Connect server can optionally sign or encrypt the output from the server, including the UserInfo endpoint as a JOT. The ID token can likewise be encrypted in addition to being signed by the server. This protection can assure the client that the output was not tampered with, and in addition to the assurance garnered from using the TLS on the connection. Then you have other parameters have been added as extension to the OAuth 2.0 endpoints, including hints for display types, prompting behavior, and authentication contact references (ACR). Using the request object construct, an OpenID Connect client can make much more fine-tuned requests to the authorization server than its OAuth 2.2 counterparts, thanks to the inherent expressivity of the request object's JSON payload. These requests can include fine-grained user claims information, such as requesting that only a user matching a specific identifier be logged in. Then you have the OpenID Connect provides a way for the server or another third party to initiate the login process. Although all canonical or 2.0 transactions are initiated by the client application, as you have seen, this optional feature gives the client a way to receive signals to start the login process with a specific IDP, as we can see in the SAML case, the IDP initiated SSO URL in a similar way. OpenID Connect also defines a few different ways to retrieve tokens, including hybrid flows, whereby some information such as ID token is conveyed to the front channel and other information such as the access token is conveyed on the back channel. This flows should not be thought of as a simple combination of existing OAuth 2.0 flows, but instead as a new functionality for different applications. It's a hybrid type, the front channel and the back channel. Then you have finally OpenID Connect provides a specification for managing sessions between the relying party and the IDP, or even multiple relying parties. Since OAuth 2.0 has no notion of the user being present apart from the moment of authorization delegation, extensions are required for handling the life cycle of a federated authentication. If the user logs out from one RP, one relying party, they may want to log out from other as well, and the relying party needs to be able to signal the IDP, the identity provider, that this should be happen. So other relying parties need to be able to listen for a signal from the IDP that a logout has taken place, and accordingly you need to react. Since the OpenID Connect provides all these extensions without breaking compatibility with OAuth 2.0. Yeah, so in this OpenID Connect, what we mainly discuss, we just try to understand why this is built like on the top of layer of OAuth 2.0, and then we need to understand ID token, UserInfo endpoint, scope, the scope mapping part. Then this we talked about this compatibility, this advanced capabilities. Then we talked about this dynamic server discovery and the client registration part. So these all things are very important, and I will just let me show you the discoverable URL to get all the endpoints, and then we can quickly discuss on I'll just show you a diagram where we can just try to understand. This is a discoverable the OIDC URL, this is our issuer address, and then this is the appendable .well known OpenID configuration, and then you will get all the endpoints here, like the issuer, authorization endpoint, token endpoint, revocation, UserInfo, introspection, end session, JWKS, registration endpoint, ping revoke, ping session management, user endpoint, and all those things, back channel logout supported, front channel. Then you have the response type, response mode, grant type, scope. So if you can see, maybe if some scope is not there, like offline underscore access is not there, which basically just requests authorization server to give the refresh token, and then you can use that to get renew the access token, as we discussed. So maybe you need to define under scope management that part so that it can be present in this metadata URL of OIDC. And then you have the different signing keys information and all the algorithm, everything. Yeah, so this is the very good metadata information which you can share with the application, or maybe application team can grab, and they can just start doing the configuration before that. Before doing the test, they can use this endpoints and they can do the configuration. In some application, they are not supposed to configure any endpoints. They just configure this OIDC metadata address only, and their application or their library, whatever they written on some class, they can easily pick that values right at the time of the token call or authorization call or the user info endpoint call, like this. Okay, now let's go back and let's quickly check this example. This is a very same example, like if you remember that auth code flow, what we did, but I just added one or more parameters here which we need to understand. So let's understand this quickly. So this is the same thing, like we have the resource owner, authorization server, the server side application, you can say, and you have the resource server. So resource owner is coming the 1 point, then going back to the 2, and then it's basically redirected. This is the front channel communication, this is the back channel communication, okay, like 6, 7, and this 8. So in the front channel communication, like the client redirected the user to the browser and to the authorization server, which with some information like response type, code, client ID, redirect URI, state. We have now scope parameter, and in the scope parameter, what we are passing, we are passing OpenID as a special scope in the OIDC thing. Along with that, we are passing profile, groups, phone, offline underscore access. So these all scopes have some meaning, right? Like OpenID will just give you the SUV value as a special scope. You need to pass that to get the ID token. Along with that, you can pass profile, groups, phone, offline underscore access, and you need to define this scope in the scope management of PingFederate, and also you need to do the scope mapping as I just shown you in that presentation. So maybe profile have the claims like user email address, first name, last name, and few other details, right? Groups have the user group information, phone is having the user phone number. Offline underscore access, this scope is basically saying, the client is saying to PingFederate authorization server or any other authorization server to give me a refresh token, which I can use to renew the access token if it expired, in a silent authentication, what we understand in the refresh token grant. Okay, that's the meaning of this offline underscore access. Okay, so now once the request will send to the authorization server will definitely just give the login and authorization prompt to the user. Once user gets authenticated, authorization server will give a consent which user has to approve. Once that is done, then in the 5th step, as you can see, the same thing, like the temporary authorization code has been sent to the client. Okay, once that is done, then in the 6th step, like through the back channel communication, the client will send that client ID, client secret, authorization code, and the redirect URI. It's a HTTP post call. Through back channel communication, it will send to the authorization server to the token endpoint. Okay, the first one is the authorization endpoint, second one is token endpoint. So once this is submitted at authorization server will generate 3 tokens here, right? Access token, ID token, reference token. Access token, as you've seen in the OAuth, right? ID token just came as we are passing some special scope in the we are just passing some special values in the scope, which basically gives us ID token, which have the user information like user details like groups, email address, first name, last name, and other details. And also you are getting the refresh token, right? Because you requested here offline underscore access, as I told. So that's why you're getting all these 3 token. So client will pass this, and it can just use how it is using. So I just put a definition here also. So what is the use of ID token here? So ID token is a JWT, JSON web token, that contains information about the authenticated user. It is intended for the client application to use to get user profile information and verify the identity of the user. It is not intended to be sent to resource servers, right? Whereas the access token, what we are doing there, it's basically the access token is used by the client application to make authorized request to resource servers. This token is typically sent to the resource server as a bearer token in the authorization header of HTTP request. So that's what we have seen, right? So this the intention is different thing, right? So refresh token is used by the client to basically renew the access token if it expired. Access token, it can delegate to the resource server, right? Which basically can give access to the protected resource. And the ID token is basically where you are able to get the detailed information about the authenticated user. Okay, you can just call UserInfo endpoint by using the access token as authorization header, and then we can see that in the Postman also. Okay, this is a basic example of or the workflow diagram of the OpenID Connect using authorization code grant. Okay, so now we understand OAuth, OpenID Connect, SAML. We need to understand the difference here. So in the next session, I'll talk about the difference. But before that, we can complete the implementation of OpenID Connect in the PingFederate, and then we can just test application, like we can onboard Salesforce using OpenID Connect, and we can do some test. Okay, so if you have anything, just put in the comment section, we can discuss. Okay, thank you.